everyone, my name is Pascaline and welcome back to the simulation class. So today we're going to create a project called an auto light, which is the automatic lighting system. So we're going to use Arduino. So the idea behind this project is for us to understand how analog sensors work and how to read values from the light dependent resistor known as the LDR, and also to use conditional statement to automate decisions, right? So for this project, we are going to be needing few components. We already have a microcontroller, which is the Arduino. We're going to need a LED res. We're going to need two LED, 1 and 2. So one is for the green and one is for red. All right, so let's just zoom out so that this can fit in, and of course use fit or just zoom out basically. So this is better. And we also need an LDR, also known as a photoresistor. So whatever works. We need a buzzer. What we have here, it's a passive buzzer. Then I'm going to put my buzzer right here. This is the LDR. I'm going to put my LDR right here. Yes, we also need resistors, and we need 3 resistors. So I'm going to get 3 resistors. So this is it. So the first resistor would be 220 ohms, which is for the LED. So you will see that there's a difference between each of the resistors colors. So once you choose, you change the color, so it changes. So this one is also 220 for the LED. So we have another resistor right here for the LED. Then for the LDR, we need a 10K resistor. So I'm going to change this right here to 10K ohms, and this is for the LDR. So I'm going to move this close to the LDR. All right, so now it's time for us to connect our components. So I'm going to connect the positive side of the red LED to the resistor. I'm going to do the same thing here, right here. And the resistor would then, I'm going to take that to the digital pin. So the digital pin, we're going to use the digital pin 4. So let's do this to digital pin 4 for the red, and for the green will be digital pin 3. So this is a digital pin 3. And for the other side, it is going straight to the GND, which is the cathode path. This is going straight to GND. So let's do this. This is going to GND. So for easy recognition, I prefer to change this to black so that anyone would understand the connection. Okay, so let's also do the same thing for our buzzer. So for our buzzer, this goes to GND as well. The black part goes to GND. So let's just change the color to black. And for the digital pin, we're going to take this to digital pin 5. So let's do this, digital pin 5. Becomes easier for us to do. Okay. Now, so this is for the LDR. Now let's connect the LDR. The LDR, the VCC goes to 5 volts. So this is coming straight to 5 volts. I'm going to do this. I just want to move this nicely to 5 volts. Yes. And the next one is the GND. So GND goes straight to negative. The GND. So this, right? So I just wanted to explain something quickly about this LDR. If this were to be a physical project, the LDR usually has just 2 pins, right? So the cases for this resistor, the resistor will be connected to AO, and from AO, the other end of the resistor will be connected to the ground. But because we're using the simulation, so it just has 3 pins. So what we'll just do is we'll just connect the AO to the resistor and the resistor to AO. I think that also works for us. So let's just do this and AO. So yeah, Okay, so this is it, and we're done with our connections, and that is the connection. So it's time for us to write the instructions, the Arduino instructions basically. So let me start with my comments. It's very important that you write comments so people understand what your project is about. So let's add comment to our project. So let me just take this here, 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 here. So where we can possibly use this, it's in smart homes, smart offices. Let me just change this, creating an auto light. So you can use it in your office, you can use it in your home. You just want to create a project that helps to detect light intensity and switch devices on and off based on the intensity of the light. So for instance, in the office right now where the light density is. You just want to check, maybe the light is fluctuating, NEPA, we don't have a very good light. So you could just use this to check to the density. So when the light is dim, so what happens when the lights it's in the room, in the office, it's very dim, a particular light comes up. So it's just to indicate, to help you know, okay, oh, this light is bad, or the power coming into the office is very poor and all that. So this is the essence of this. So now let us just, it's time for us to declare our variables, declaring variables. So we're going to be declaring our variables right now for each of our components that we have used. So we're going to start with the LDR. So I'm going to declare it as const int LDR pin. It's best when you're naming to use a camel case. So it's there. So always terminate, very important. Now for the green LED, so we're going to do this. So green LED, and this is very important, and so we use 3. So let's do the same thing for the red. We have int means integer basically, so integer, so 4. So it's time for the buzzer. Remember that for the buzzer we used what's the token. So let's go to buzzer. So let's declare for buzzer int buzzer equals to 5. Always terminates, all right? Because on Walkway we use a passive buzzer, and there's a difference between passive buzzer and an active buzzer. So passive buzzer requires that a program to work, and it can actually be used if you want to make tunes, want to make music. But an active buzzer, you can actually not use it to create music. It just gives same sound. And to turn on the active buzzer, you actually need to use digital write, high. But for passive buzzer, you need to write tune, uses tune or no tune. So that's just it. So now we need to get the threshold. LDR uses a threshold, so we need to get the threshold value for which will determine whether the room is bright or dark. Like I said, this experiment is just so when there's fluctuation in the light, is just for you to know that the light is stable in your room or not. So this is basically what we're trying to achieve right now. Okay, so let us start. So let's go to our setup immediately. Let's configure. Let me just change this. Let's configure the LEDs, configure components. So your LEDs are output devices. Okay, so we're going to be using pin mode, green LED output. Never forget to terminate. Pin mode, red LED, it's an output device. Same thing for your buzzer, is also an output device. So let's also configure the buzzer, it's an output device as well. So we have buzzer, so it's an output device, and so we're terminating. So we want to use a serial monitor right here to just display something at the bottom, because of course this is a simulation. So we're going to use serial dot begin, because you need to begin. And for Arduino, it uses a 9600. This is Arduino Uno. Then serial print line, print line. Please, and it's very case sensitive, so ensure that's what you're doing. So we just say auto light system started. So this is basically just a light to make it, not too serious, and just moving on. So now let's go to the major place where the instructions will go, where we want our code, which is in the void.loop. This is where we're going to be reading. So let's start by reading the intensity of the light. So let's read light intensity. Now we're going to create a variable for the light value. So light value, remember I said it's best to use camel system in naming your variables. So analog read, so you can see that is already set up for analog read. We're going to read the LDR pin. Remember we declared this right here, so we're reading the analog pin right now, and we're going to terminate. Now let's display the sensor value. So have serial dot print, because I want to display the sensor value. I'm not going to use print line, so because the next value you're going to see what I'm going to do right now equals to, or just with light level. Then I terminate this line of code. Always terminate, so that's the mess. So then I'll use the next one, serial.print line, because now I'm going to be using this path. I'm going to print this. So that what's simply saying is that this value, the LDR print, should be stored in the LDR value. So I hope you understand that. Okay, so let's continue. So now it's time for our conditional statement. We're going to test for a bright environment, if the environment is bright. So what happens? So let's begin. If light value is greater than threshold, if the light value is greater than threshold, so what should we do if our light value is greater than threshold? Then the green LED comes up. Okay, so digital writes green LED, it's become high, and you turn off the red LED, so that's low. It's a Boolean values basically. So we don't want the buzzer emitted any sound, so we're going to use no tune and no tune buzzer. So what if, and the status, we're going to print a status for it, serial.print line status. We're going to print a status. The status would be bright environments. That will be the new status that will come up once this is. Then here, else if that is not the case, if we have a dark environment, if there's a dark environment, what would happen? Then the digital writes, the green LED would obviously turn up, green LED would go off, I need to see what I'm typing. Okay. Digital write, red LED would be high, and of course digital write, our tune, so tune buzzer be 1.5, so it turns on the buzzer that the environment is dark or the environment is not so cool. So let's do a serial.print line. So for the status, it says status dark environment. So this is basically it. It's just to show that this is what is happening. Then let's just add a delay. This is just a wait seconds, just to wait for a few minutes, and it goes back again. The loops observes, goes back again, and all that. So this is just the end of the project. So it's time for us to test this project that we have done. So first I'm going to save this and I'm going to simulate, and let's see. It's going to run, it's compiling, and once this is done, like I said, this is just to check for dark and light environment. This is just basically for environment monitoring, depending on what you want to achieve. This can be created to be more advanced than this, but this is just using LDR resistance on its own, and it's just all about detecting light. That's the essence of the LDR sensor. There are different sensors. There's the ultrasonic sensor, there's the motion PRL motion sensor. There are a lot of sensors. It's based on what you want to achieve, right? There's the temperature sensor, that's the DHT11 or DHT22. So there are different sensors, and there's the soil moisture sensor. So different sensors for different purpose. But for this purpose, for the auto light, we're using the LDR sensor basically. So we're going to wait for this to come up, and we'll see our simulations. Sorry, I forgot to declare for the threshold, so please, yes, we have to declare a variable for the threshold. Let's do that. So int threshold, this is a constant threshold, so just get threshold so that this is, or else would. So another thing that I can see, instead of having like declaring a threshold, we can actually use a potentiometer. This is another component which helps you know when you have like bulbs to turn on and turn off, which is, see, I already have an error. Thank God I quickly did this. So threshold that's very important that you change these things, because imagine without that. So now that this error has been removed, I just will not encounter this error anymore. Yes, let's hope there's no error in the code again. Yeah, so it's very important because programming is all about making mistake, correcting yourself, understanding what is the most important thing is understanding why things are needed. So the threshold basically it determines whether the room is considered bright or dark, and we're using a fixed threshold, which is the 500. So if we don't want to use a fixed threshold, we can actually use a potentiometer, which we can use to adjust the threshold. It's like when you have like a component that helps you just adjust tune, when you're tuning your volume, that kind of thing. So that's the function of a potentiometer. So that can actually work. So we can use that to rotate, to turn down threshold. So at this value, what happens? At this other value, what happens? So that's basically. So we're just waiting for the simulation to see our project. You can see our project is working, our simulations is working. So look at the threshold and it's changing. You can see that the green. So did you see that? So let's change at this. We have this. What if the is not it? So this is it. So the brightness level. So you keep getting the brightness level of this, of this, of this, of this. So let me just start it. So this is a dark environment. That's why you have this. So it is the illumination is 4. What if the illumination increases? Let's see. So are you seeing now? Let me increase my illumination. Did you see that? If this is a stable environment, but anytime the illumination reduces, it goes back to there. So this is basically how it works. So thank you and see you in the next class. Bye.